Hello everyone, this is SafePlate. And what is SafePlate? SafePlate is a tool designed to make dining safe and enjoyable for people with special requirements. It not only replaces restricted ingredients, but also tries to preserve the original taste. It is important due to the dietary restrictions are becoming increasingly common due to allergy or lifestyle choice. Not everyone is good at knowing the best ingredients to substitute in a given recipe and knowing what are dangerous to them and what are not. And hence, SafePlate comes to rescue. Let's break down our architecture into two parts, one generator and one validator. The user first has to input three things: the dish name, the original recipe, and their special requirements into our generator to get our modified new recipe. And here, validator will come out to assess on the modified recipe on its rawness, safeness, and tastiness, and categorize it to 1 out of 3 levels, which are safe, caution required, and not safe. And if it's safe, then the recipe is proved to directly present to the user. If it's caution required, it means there is some minor issue within that recipe. So the validator will provide with some instruction and explanation on how to proceed the dish safely, and it will send that instruction along with the recipe to the user. And then lastly, not safe. If it's not safe, the validator will also provide some explanation on why it's not safe. But this time we will bring that feedback, send it back to reprompt our generator to try again on the same recipe. If after two iterations it still failed to approve that, we'll reject to provide the recipe. And now let's dive into our first example. Say if we want to make a shrimp fried rice, and we want this to be no shellfish. The safe recipe gave us, the SafePlate gave us a recipe that replaced the shrimp with the fried tofu and replaced the soy sauce with the tamale sauce, which is a better sauce for tofu than the soy sauce. This highlights how the model can both maintain the intended flavor, but also avoid the restrictions. And then this is an image of a tofu-made shrimp. And our next sample is long bean pork stew, and we want this to be nut-free. This time, SafePlate gave us a caution required recipe instead. And if you jump into the caution section, it says if you're using the sunflower oil, be careful that the sunflower oil might contain cross-contamination with nuts during the production in the factory. So if you have severe allergy to nuts, you probably want to buy those sunflower oil that is clearly labeled as nut-free.
Up next, the data collection and processing. We have two datasets, each serve for a different purpose. The first one is a validator dataset. It is a manually labeled dataset aimed to verify the functionality and performance of the validator agent. It contains 3 categories: safe, unsafe, and caution. For each category, we aim to cover all possible scenarios with an emphasis on the unsafe cases. The next one is an availability dataset, stemmed from the recipe NLG, and aims to test the availability of the food system. And the process method is combine the recipe with a random requirement, such as allergy-free or serve for special kind of people, like pregnant people. And the performance. The validator has an overall 85% of accuracy on the validation dataset. It may not sound promising, but if we break it down, we can see that for the safe cases, it never mislabeled it as unsafe. And despite a few complex cases involve chemical reactions, it never labeled an unsafe case to safe. And most importantly, it never missed an allergy-related case. For the availability dataset, our model succeeded in generating recipes for over 99% of the cases within 2 attempts. It is acceptable because the failing cases majorly occurs on extreme scenarios when the requirement itself is inherently risky. And as a conclusion, we believe our model is reliable and practical to use for most of the daily scenarios, like making a common recipe allergy-free or substituting a given ingredient into something else for nutrition or availability reason, and adjusting the cooking steps accordingly. And lastly, what we learned from this project. The project actually brings several valuable insights. And first of all, is integrating AI into a specific application demands a lot of domain knowledge. And surprisingly, most of our time is not spent on prompt engineering. Instead, the time is spent on creating a comprehensive and validation dataset for the validator agent. So for the future project, we'd prioritize consulting domain experts early, and especially for creating a validation dataset. And that's it.